Hello, I'm Anna Mackay, and today we're looking at the vector between 2 points. So imagine our x and y axes, and imagine the 2 points that we've got. And essentially we're sort of trying to find the distance between those two, but we're now talking in terms of vectors. So we've got our origin here, and imagine we've got A, the position of point A is here. Now, think about what its horizontal and its vertical components are. How do we work out the coordinates of A, is what I'm trying to say. Well, A1 would be its horizontal component, and its vertical component, let's call it A2. So we've gone across that far and up that far. And imagine that to work out what number they correspond with, you would go across to the axes and see what number that hits. Yep, that's nothing new. And so therefore the coordinates of A would be A1, A2. Sorry if you can't quite see that 2 there. Now what about B? What would its coordinates be? Well, what's its horizontal and its vertical component? What you would do is you would essentially go down and across to the axes until you hit them and you see which number they line up with. And we would have B1, we'll call it there, and B2 for the vertical component. So B's coordinates are B1, B2. Now the vector AB is represented like this, starting at A and ending at B. And that's called the position vector of B relative to A. So when we're talking about the vector B relative to A is the second one that's mentioned there, but that's actually where we start. So we're finding out where is B in relation to A, so where we started from. And we call that AB. Now, what are the components of that is what we're trying to work out. So what is the horizontal component? What's the vertical component of that vector? So our horizontal here is essentially how would you work out what that number's going to be? Well, let's have a look. You've got the B1 and the A1 there. So it's that distance between those points. So if you come down to the x-axis, you would see how much that is. Let's say it was B1 was 5 and A1 was 3. How would you work out the difference between them? You take the difference. So you subtract, you'd get 2 in that case. And so you would have the B1 there subtracting the A1 component, and that'll give you the number here. Same idea goes for the vertical component. How would you work out that distance? You would head across to the axes if you like, and you've got the B2 up there and the A2 here. How do you work out that distance? It's the big number, take the small number, or the second number, take the first number, and the difference is your answer. So this first one here, we've got B1 take A1, and notice that they are the two horizontal or x components of the vectors. So see where B1 is up here in point B, it's the x component, subtracting off the x component in A, and therefore for the vertical part, the B2, so take A2, so you can see that comes from the axes there, it's the difference between those two heights, and the B2 is in the y position of point B and in the y position of point A. So it's this first components work together and the second components work together. And this is how we would write that out. So the position vector of B relative to A, it's a subtract there. It's the difference between the one that's further along and where you started, and same for the second position. Just thinking about it in a slightly different way here, we've got point A and point B. And so the vector of A, notice where it's coming from the origin here. Little letter we're using here for B. These are called the position vectors. So in relation to the origin, that would be this component here with the A, but of this vector here, AB, A and B are position vectors of A and B respectively. The vector of A relative to B. So this time round, we've got A first and then B. Now how do we create that vector? We want to start at A and end at B. So here's our beginning. If we have to come down this red line of A and up this red line of B, actually we're doing negative A here, so we have to go backwards along A and then add on B. So that's how we would get the vector AB. Or how could we rewrite that in a slightly different way? If we put B first. So noticing here, if you have the vector AB So that's the vector of B relative to A. So A is where you start. You're actually taking the B part first and subtracting off A. So you might think of it in a couple of ways. Which order do the letters come in here? A then B. But here it's reverse. So it's B subtract A. So making sure that's written down for you to remember. What if it was the other way around? What if it was B to A? Which one comes first? The A comes first and then you subtract off the B. So you'll look at the components for that. When you come to do questions that might look like this, you've been given A and B and you're asked to find the position vector of A relative to B. So you'll get asked that a lot. You'll be asking yourself, well, which way around is it? Is it A to B or B to A? So go back and read it. Of A relative to B, drill this in. The second one is where you start. So it's relative to B. B is mentioned second, so that is where you start. So where is A in relation to the beginning of B? And so that's what that one would look like. And if you get asked about the position vector of B, that's just B on its own in that sense. So it's from the origin up to B. So it's whatever that is, that component, which we often represent as little letter B. One example here. So we have a circle and we know that AB is the diameter of the circle with center C and coordinates of B. Part 1, we're asked to find BC. Okay, so B to C, you'll need the two coordinates of B and C here. So I'm going to write this out. Okay, so as we've just learnt, you take the second one first. So C is in the second position. So we're going to look at the coordinates of C first. So that -1 is in the X position. And now you do a subtract and you go over and you look at 3 for B because they're both in the same corresponding positions. And then it's a comma. And now you look at C again because you start with the second one first. So we've got the 2 here and it's a subtract of what's in the Y position for B and it's a 1. Square brackets and there's our vector BC. So part 2 here, find the coordinates of A. Okay, so we don't know them yet. So let's let A have coordinates AB. First of all, let's work out what vector C to A is. So once again, you look at which letter is second. A is second, so we need to start with the components of A first. So the first part of A is A, and it's a subtract. Sorry, ignore my comma there. That's a subtract the component of C, so it's -1, so that actually turns into a +1. Comma, you now look at the Y component of A first, and that's B, and you subtract off the Y component of C. So that's our vector CA. What fact do we know though? Being a circle, C to B is a what in the circle? A radius, and therefore C to A is also a radius because C is the center, we've been told. So we can write out a fact here that vector CA is equal to vector BC. So that therefore means that the distance, if you like, will be the same. How do we write that out? Write these out now with their components. So I've written out vector CA there, and I'm going to put it equal to vector BC, which we worked out in part A, -4, 1. And now you're essentially equating components. So A plus 1 is equal to what's in that first position of B, the horizontal component, is equal to -4. Haven't done that very well. So therefore A is equal to -5, and B subtract 2 would be equal to +1. Therefore B is equal to 3. Don't just leave it there. Go back and read the question. What did it ask you to find? The coordinates of A. So it's quite neat to finish it off by writing A is -5, 3. And that's how you'd solve that question. Okay, join me for the next video, 3G.1, parallelism and unit vectors. Thank you.